Introduction to isomers. Well, the keywords I need to talk about: molecular formula, structural formula, and spatial arrangement. These keywords are very important in understanding isomers. So what is molecular formula? Here's an example of a molecular formula where you have a naming of the elements in the compound, and a structural formula will be the display of the formula. So there's a structural formula here. And spatial arrangement would be the way these structures are arranged in space. So this is a spatial arrangement because this one is here, over here, and this one is there, over there. So this is spatial arrangement difference. So now let's look at isomers. There are two main types of isomers: stereoisomers and structural isomers. The structural isomers are often called constitutional isomers. Structural isomers are isomers with same molecular formula but different structural formula. Stereoisomer, same molecular formula, same structural formula, but different spatial arrangement. So here's an example of stereoisomer, because this is the molecular formula and the structure is the same. That structural formula is same as structural formula for that, but there's a different spatial arrangement. This one here is different from there, in a different position in space. And that's what we mean by spatial arrangement. So stereoisomer have same molecular formula. These two are the same molecular formula, same structure, but different structural arrangement. Structural isomer have the same molecular formula, but different structural formula. Here's an example of structural isomer. Carbon chain. A carbon chain isomer. Let's look at the molecular formula of that carbon chain. An example of that is a butane or 2-methylpropane. Same molecular formula, different structural formula. Another example, position isomer. A position isomer will have, let's look at the molecular formula and then look at the structure: propan 1-ol, propanol, or you might have propan 2-ol. So different position number 1, 2, 3, and position number 1, 2, 3. So in the position number 1 here, hence the name position structural isomer, and position number 2 here. Next one is functional group isomer. Molecular formula, let's look at the structure: ethanol and C2H6O, that's ethanol, or you might have ether. So same molecular formula, different structural formula. The final example is tautomerism. With tautomerism, we got a molecular formula and we got a ketone, that's one structure, and another structure in equilibrium with the ketone will be enol. Enol is slightly different in structure, but same molecular formula, but different structure. Now let's look at stereoisomer. There are two types of stereoisomer: diastereoisomer and enantiomer. Let's look at example of enantiomer. We got optical isomer, and here's a structure, 4 different groups here, and chiral center. We got a mirror here, and you having a mirror image, and this is non-superimposable. So that is an optical isomer. For diastereoisomer, there are 2 examples of diastereoisomer. One is geometrical isomer, conformational isomer. Conformational isomer is an example of rotamer, things like a chair or boat structure. But the geometrical isomer is split into 2. One is cis-trans isomer, and the other one is EZ isomer. An example of a cis-trans isomer: this has to have a double bond structure. Double bond structure do not rotate, unlike single bond will rotate. The cis-trans isomer has same molecular formula, same structural formula, but different spatial arrangement. Here's the second example. These are both isomers, same molecular formula and structural formula, but different spatial arrangement. Carbon attached to the double bond will have to have same species on both sides, like hydrogen and hydrogen. This might be different or they might be the same, but one of them has to be the same. Unlike here too, one of them has to be the same. If they're on the opposite side, then that's what we call trans. If they're on the same side, we call that cis. This one will be called cis pent 2-in. This is 1, 2, 3, 4, 5. That's pent for 5. 1, 2, because double bond is in the second carbon, so that's why it's called 2. Cis pent 2-in. The in indicates double bond. In the opposite side will be called trans. So this one will be trans pent 2-in. But if we have a structure which is slightly different to this one, where you have different structure completely, or different species on the carbon bonded to the double bond carbon, on the carbon bonded to the double bond carbon. So that carbon will have a different species. They're not the same, and that carbon will not have the same species. Then we may use something called EZ. With EZ, which was introduced to us by these 3 scientists, and their names are Can, so C for Can, Ingold, I for Ingold, and P for Prelog. They introduce a way of working out the cis and trans when the species are all different. So if the species are different, we use something called priority rule. And that priority rule is referring to the carbon with the biggest atomic number will have a higher priority. Here's an example. The double bond carbons, and we got fluorine and bromine. If we look at that carbon, which species has higher priority? Is it fluorine or bromine? It will be bromine because it's got the highest atomic number of 35. Priority number 1 and priority number 2. On the left-hand side of this carbon, the higher priority will be chlorine because it's 17 atomic number, priority number 1 and priority number 2. If the higher priority are on the opposite side, like that, we call that E isomer. And E stands for entgegen, which means opposite side. But if the higher priority on both sides are on the same side here, we call that Z isomer. Z stands for zizem, meaning same side or together. Because they're together, that's a Z isomer. We can use EZ isomer for this structure too, but this is more appropriate because hydrogen has a low priority and carbon has a higher priority. So this will be priority number 1 and that's 2. And this is 2 non-priority and that's 1. This will be trans or E isomer and this will be Z or cis isomer. But where we cannot use the cis and trans isomer, then we need to apply the CIP rule, the priority rule. In this case, we would need to apply the priority rule. But note, you must have a double bond and you must have 2 different species attached to the carbon here and 2 different species attached to that carbon. But for cis and trans, one of the species had to be the same on both carbon. Hence, in this case, hydrogen is the same in both cases, and that's good. But when you're using EZ isomers, they don't all have to be the same, but have to be 2 different species, another 2 different species, and none of them have to be the same on both carbon. Hence, we have to apply priority rule by CIP or CIP. So to summarize, there are 2 types of isomers. One is structural isomers and stereoisomers. Structural isomers have the same molecular formula but different structural formula. And for stereoisomers, they have the same molecular formula and structural formula are the same, but spatial arrangement is different. There are 4 structural isomers: carbon chain isomers, position isomers, functional group isomers, and tautomerism isomers. Same molecular formula, different structure. Unlike stereoisomers, we have distereoisomer and enantiomers. Enantiomers are optical isomers which has mirror image. Here's a structure with its mirror image. Same molecular formula, same structural formula, but different spatial arrangement. The distereoisomer has 2 different isomers: geometric isomers and conformation isomers, which are rotamer isomers. But they are like a boat shape or chair shape isomer. And for geometric isomers, which is what we're interested in, we can have cis trans isomer and EZ isomers. For cis trans isomer, you must have a double bond. For geometric isomer, actually, for geometric isomers, you must have a double bond because double bond do not rotate. Only single bond can rotate. So this has a fixed shape, and that fixed shape can have two different type of structures. Same structural formula, but different spatial arrangement. Again, have same structural formula, same molecular formula, different spatial arrangement. That is different to that. For cis-trans isomer, you must have at least one of the species attached to the carbons must be the same, either on opposite side or on both sides. When they're on opposite side, we call it trans, and when they're on the same side, we call it cis. For EZ isomers, we apply SIP rule, which is priority rule. We apply the highest priority to the highest atomic number. In this case, bromine is 35, so the atomic number for fluorine is 9, so this one has a higher priority and second priority. Chlorine is 17, and that has a higher priority, and hydrogen has a second priority. If the higher priority are on both sides, then it's a Z isomer. Z stands for zizamine, and if the higher priority on the opposite side, then that's E isomer, and E stands for antgegen, which means opposite side.